Domain and range. Suppose you have the function g of x is equal to 3x minus 1. The domain are the input values. Although I'll update that a little bit more later. The range is the output values. Now, it's not just any input value, it's in the domain. It's an input value that gives back an intelligent answer. G of 5 is 3 times 5 minus 1, which is 15 minus 1, which is 14. 14 is a very well-defined number. This means that 5 is in the domain. The domain for G. G of 2. It's 3 times 2 minus 1. It's 6 minus 1, or 5. So 2, the input, since we got back an intelligent answer, 2 is in the domain. The domain of G. Now, if I give you h of x is the square root of 10 minus x, well, let's see. H of 6 is the square root of 10 minus 6, which is the square root of 4. I can even break that down. Since I got back an intelligent answer, we say that 6, the input, 6 is in the domain. H of 7 is, well, 10 minus 7. It's the square root of 3. That's an intelligent answer. So 7, the input value, is in the domain. Now, h of 14 is, well, 10 minus 14, the square root, which is negative 4. This is not an intelligent answer. The square root of negative 4 doesn't exist. So, 14 is, the input value 14 is not in the domain. The domain is the set of x values that I can put in and get back an intelligent outcome. For the record, the numbers, the intelligent numbers that we get back, not this one, 2 and square root is 3, they're in the range. So let us do this more formally. We only found some numbers in the domain, some numbers that isn't in the domain. Suppose you come to know that g of x is 3 over x minus 5. Now, what number or numbers, if any, can you put in there? Now, sometimes it's easier just to say what numbers you can put in there. Now, any number I plug in for x, I can take away 5. I can take away 5 from any number. I may not like some of the numbers you give me. Now, if you give me 0.003721445 and you ask me to take away 5, that's not going to be friendly. It's going to be negative 4.99627.855. It wasn't easy. but I was able to do it. I can take away 5 from any number, and the top number is always 3. So I can always get the top number. I can always get the bottom number. Now we have to think about division. So I'm definitely dividing 3 by a number. What can I not, or what can I divide 3 by? I can divide 3 by every single number except 0. I can divide by 0. So the domain will be, the denominator can't be 0. Add 5 to both sides, and the domain is x cannot equal 5. That is the final answer. X cannot be 5. Okay, because if x is 5, I get 3 over 5 minus 5, which is 3 over 0, and I don't know what that is. Well, actually I do. It is undefined. There is no number that I can put there. 0 times no number gives me 3. 0 times whatever number I put there will give me 0. This is undefined. I can't just figure out any number. Okay, so the domain is all numbers except 5. Now, suppose you have that h of x is equal to the square root of x plus 3. Now, there are 3 types of numbers: negative numbers, the numbers 0, and positive numbers. You can take the square root of positive numbers. You can take the square root of 0. You'll get 0. You cannot take the square root of negative numbers. So what's under the radical sign, it can be 0 or positive. It can be bigger than 0, or it can equal 0. Well, what type of numbers can you add 3 to and get positive or 0? Numbers from -3 and above. And if you take away 3 from both sides, you will see that. By design, the 3's cancel, and you get x is bigger than or equal to -3. That is the domain. All numbers -3 or larger. Suppose you have the following function. F of x is equal to the square root of 4x minus 2 divided by x minus 7. Okay. What is the domain? Well, there are 2 constraints. What is under the denominator has to be at least 0, and their denominator can't be 0. Just 1 is not enough. If I make what's under the radical positive, that doesn't mean that this means that x can't be 7. Okay? If I make what's under the radical positive, that doesn't mean that x can suddenly be 7. And if I don't pick 7 for x, that means the denominator won't be 0. That doesn't mean what's under the radical will be positive. Both statements must be true. This box statement and this one, they have to both be true. It's not or. Or means one or the other, or both. In mathematics, or means and or. It means and or. Okay? But we don't have an or. We have an and. If I add 2 to both sides, then 4x must be bigger than 2. Divide by 4. X must be bigger than a half. And x can't be 7. Now, if this had said x can't be negative 7, well, if you're bigger than a half, you're already not 7. So I would just say x has to be bigger than a half. This would be redundant because this already says that x can't be negative 7. It says x can't be negative 4. It says x can't be 0. It already includes a lot of values that x cannot be. So, in terms of a graph, so here is one way of writing the domain. So, let me get rid of this because that was an example. X is at least 1/2 and it's not 7. Well, maybe your teacher wants you to draw it on a number line. So here is a half. It can equal a half, so it gets filled in, and it can be greater. But it can't be 7. So you come to 7 and you put an open circle. That's one way of writing the domain on it. That's the way of writing it on a number line. Interval notation is x can be in between here or here. X can be in between a half and 7. It can equal a half, but it can't equal 7. Or union or, x can be bigger than 7. That would be this piece here. This piece here is x is bigger than 7. Well, this piece here is in between. It has a start and a finish. X is in between a half and 7. It can't equal a half. So this is another way of writing it. Depending upon what your teacher wants, it might be, write it one of those ways. Suppose you have f of x is the square root of x minus 2 divided by x plus 10. There's two things to be concerned about for the domain. What's under the radical has to be at least 0, and x plus 10 can't be 0. You can't divide by 0. Well, you add 2 to both sides, and you know that x has to be bigger than or equal to 0. And take away 10 from both sides, x cannot be negative 10. Well, if x is 0 or above, yeah, I agree, x can be negative 10. I mean, it wasn't like I'm including negative 10 from the first part and then I have to remove 10. No. This negative 10 is said to be redundant. So we can just say x is bigger than or equal to 0. This here is the same as this one. Here it is on a number line. Interval notation, we can go with from 0 to infinity. Why didn't we do that in the last problem? It can go from 1/2 to 7. It can include a half but not 7, or it can go from 7 to infinity. Don't include 7. Infinity and negative infinities are not numbers, so never include them. It goes up to infinity, but it's meaningless to include infinity. It has no meaning. Suppose you have the function g of x is equal to the square root of x minus 10 minus the square root of 15 minus x. Now, just because what's underneath here may be positive. For example, if x is 25, 25 minus 10 is 15, and you can take the square root of 15. But the problem here is 15 minus 25 is negative 10, and you can't take the square root of negative 10. We need an AND statement. X minus 10 must be greater than 0, and 15 minus x must be greater than or equal to 0. Well, I can add 10 to both sides, and by design the 10's cancel on the left, get x is greater than or equal to 10. Taking away 15 from both sides, don't lose the negative. Negative x is greater than negative 15. I'm going to multiply both sides by negative 1, so I'll get x and 15. But if you multiply or divide an inequality by a negative number, you have to change the sign. Okay, so x has to be 10 or more and less than 15. And so here's 10, here's 15. The first statement tells me I can be 10 or more. The next statement tells me I can be 15 or less. Where are they both true? Wherever the lines overlap. The lines overlap everywhere in here, including the endpoints. That is, the final answer in terms of a number line is from 10 to 15. That's one way of writing the answer. Another way is between 10 and 15, including the endpoints. Another way is the interval from 10 to 15, including that. Some teachers like set builder notation. The set of all x such that what? That x is between 10 and 15. This bar means such that, and that bracket means the set of all. So how you read this is the set of all x such that x is in between 10 and 15, including both endpoints. Do not read the last bracket. Suppose you have this problem. H of x. So, I just want to say one thing. So, all of this is the domain. That's the domain. That's a way of writing the domain. That's another way of writing the domain. And the set builder notation is another way of writing the domain. Okay, good. Here I wrote it. So this is one way of writing the domain. This is another way of writing the domain. This is another way of writing the domain. I mean, set builder notation would be the set of all x such that x is bigger than 0. Okay. So let us do this problem. You have x over x minus 2 pi all under a radical. Well, now remember, this is the square root of x divided by the square root of x minus 2 pi. So what's under the first radical, the top one, has to be at least 0. What's under the second radical must be at least 0, and there's a denominator. The square root of x minus 2 pi cannot be 0, which, if you like, you can just write as x minus 2 pi cannot be 0. So the first one is solved. X is at least 0. Add 2 pi to both sides. X is at least 2 pi. And add 2 pi to both sides. X cannot be 2 pi. Okay, if we were to graph these three, 0 and 2 pi came up. The first one says x must be 0 or above. The next one says it can be 2 pi or above. The third one says it can be every number except 2 pi. It can't be 2 pi, but it can be larger, it can be smaller. Which numbers, if any, which numbers are on this number line, on this yellow number line, have all three lines above them? Well, for example, this point here, it only has one line above them. This point here, it has 2 lines above them. The point 2 pi only has 2 lines above them, because the third line doesn't have a point there. But anything to the right of 2 pi, anything to the right of 2 pi, have all 3 lines above them. Why, or 3 points above them? Why 3? Because there were 3 restrictions. So the final answer is x has to be bigger than 2 pi. In our interval notation, here's 2 pi. Number line notation, it can't be 2 pi. It can be bigger. This is one answer. This is the second way of representing the answer. You can write it in interval notation from 2 pi all the way up to infinity. Never ever include plus or minus infinity. And in this case, it is bigger than 2 pi. It cannot equal 2 pi. Or the set of all x's such that x is bigger than 2 pi. It's this one pretty much, but there it is. But in set builder notation, the set of all x such that x is bigger than 2 pi. Now, suppose we want, so now let's talk more about the range. Suppose f of x is 1x plus 2. Now, since this a horizontal line, it has slope 0, and a vertical line has slope infinity. This slope or no slope. This has neither of those for slopes. It's one. That is, it goes up forever and it goes down forever. It hits every possible y value. Is it ever this value? Sure. If you take f of that number, you will get that number. Does it ever hit this y value? The answer is yes. If you take f of this number, you will get that y value. This line, I claim, can equal every value there is. Now, to prove this is, let k be any number. So I want to know when x plus 2 is k. Well, of course, if you let x be 2 less, it'll work. But to formally see it, let's take away 2. Okay. I claim that when x is k plus 2, I will get back k. Who knows? Maybe I'm wrong. F of k minus 2. This says to take what's in the bracket and add 2 to it. Okay, I take what's in the brackets, I add 2 to it. Now I do math and I say, oh, that cancels. Oh, yeah, I do get back k. That is, if you want to get 113, here's the recipe. Let x be the number you want minus 2. And check this out. F of 111 is x plus 2. Yeah, I really did get back 113. Any number you want. If you want to get back negative 7, let x be 2 less. Negative 7 minus 2 is negative 9. Let's see if I'm right. F of negative 9 is that number plus 2. Oh my goodness. I did get back negative 7. And there is no restriction on k. No matter what k is, I can take away 2. So f of x for any k, f of that special x value will give me back k. I can achieve any y value I want. So the range is all real numbers. Maybe you can use this symbol for real numbers. Maybe you have to use this type of notation. X is between negative infinity and infinity. Maybe interval notation. Negative infinity to infinity. Maybe number line notation. I'll put down some numbers. 0 can equal 0 and everything to the right and everything to the left. That is the range of f of x is equal to 1x plus 2. It can equal any value. Now, suppose you have the function f of x is equal to 3x squared minus 4x plus 5. And we want to find the range. Now, you should know what this looks like, at least a little bit. It is a parabola. It is a positive parabola. A positive parabola goes like this. That's the lowest point. If that y is 7, then the range would be y is 7 and above, because it goes from 7 all the way up. even on the left side, from 7 all the way up. And if this y value, if this min was 71, this graph takes on all values 71 and above. If it's negative 71, then it's the range is y is negative 71 and above. The point is, find that point. Now, this x value, the x value right here, is negative b over 2a. Remember, that's a, not because it's first, but because that's what x squared is being multiplied by. This is b. So we get negative, b is negative 4, divided by 2 times 3. We get 4 over 6, which is 2/3. So what you want to do is find f of 2/3, which is 3 times x squared minus 4 times x plus 5. They put 2/3 in, or you put 2/3 in. Well, we have to put 2/3 in. So it's this number minus that number plus that number. 3 times 2/3 squared. Well, we have to figure out what those numbers are. The first number is 3. The second number is 4 over 9. 3 goes into 9 3 times. We get 4/3. So it equals to 4/3 minus 8/3. And I'll write 5 with the 3 in the bottom. 3 times 5 is 15, plus 15 over 3. Well, 15 plus 4 is 19, minus 8 is 11. Okay, so what I discovered was the following. Let me erase this, please. What I discovered is that the min value is, well, x is 2/3 and y is 11/3. The min value is right there, and it goes up forever, and it goes up forever. The range is the y values. Y is at least 11/3. You can say 11/3 to infinity. It can equal 11/3. You can say that y is in between 11/3 and infinity. Don't include infinity. You can say here is 11/3. Y, the range includes 11/3 and above. You can say that it's the set of all y such that this is true, or that. I mean, these two are the same statements. Y is bigger than 11/3. If it's a parabola or quadratic, you should know what the range is. You should know how to graph it. What if I tell you that h of x is equal to 2x minus 5 square root? Well, I want to know, when can h of x equal k? K is some number. That is, I want to know when this equals k. So I square both sides. 2x minus 5 is equal to k squared. I add 5 to both sides. I get that 2x is k squared plus 5. I divide by 2, and I get x is equal to k squared plus 5 over 2. But there's one slight thing here. I know right away I can't be negative. So k has to be at least positive, or 0. Has to be at least 0. And I can get any number. See, if we had that x has to be k squared plus 5 over 2 minus k, well then k can't be 2. Because if k is 2, we want to take f for something to get 2. But we would have to take 2 squared is 4 plus 5. We'd have to take f of 9 over 0. But you can't take f of undefined. But there is no problem because the denominator is okay. I can square any number 0 and above. I can then add 5 to it, and then I can divide by 2. So the fact that there's no restriction on k other than this restriction. Remember, h of x has to equal to k, where k is positive. So the range is y can be at least 0. Now, let's see what this is all about. What does this mean? Well, if I pick k, let k be 5. So then x is 5 squared plus 5 over 2. It's 25 plus 5 over 2. It's 30 over 2, or 15. I claim that if I take h of 15, I'll get k. Well, let's see if I'm crazy or not. H of 15. Well, it's 2 times x minus 5 square root. And I plugged in 15. 2 times 15 is 30. Take away 5 square root. 30 minus 5 is 25. Look at that. I was able to get 5. Since I was able to take h of something to get 5, that means 5 is in the range. And I can get any value bigger than or equal to 0. I mean, basically, what is h of? Now, k is just some positive value, okay? K is some positive value. Well, the rule says whatever in the brackets, I multiply by 2 and I take away 5. And I compute the square root of it. Well, the 2's are going to cancel. So I have k squared plus 5 minus 5. That's just k squared. And the square root of k squared, if k is not negative, it's greater than or equal to 0, I get back k. Okay, I can take h of something and get back any positive k value. That is why the range is at least 0. This is heavy duty stuff, but you have to be able to do this. What if I tell you that g of x is equal to x squared minus 9? Well, we know that this is either 0 or positive. And possibly we can't even get those values. But it can't be negative, okay? So let's see if we can get back any old k. Any old number 0 or above. Let k equal, let k be bigger than 0, be any real number, any real positive number. Okay, so can I take g or something and get back k? Well, square both sides. X squared minus 9 is k squared. Add 9 to both sides. We get that. So x can be plus or minus this. Now, the least x squared k squared can be is 0. There are 3 types of numbers: negative numbers, and numbers 0, and positive. If k is negative and you square it, it's positive. If k is positive and you square it, it's positive. If k is 0 and you square it, you get 0. The least you're going to get is 0. K squared is 0 or more. But then you add 9. If you add 9 to a positive number, you add 9 to 0, well, what you get is more than 9. You get 9. You get more than 9. If you have a positive number and you add 9 to it, you'll be more than 9. 9 plus. Okay, you'll be at least 9. Well, you can take the square root of numbers 9 and above. Okay, so I claim I found my x. In fact, I found 2 x's that I claim would work. Well, suppose I want to get 7. Suppose I want to get 7. So I'm claiming that x should be plus or minus 7 squared plus 9. 7 squared is 49 plus 9. That's our plus or minus 58. Okay, so what is g of any of those 2 numbers? Well, the first thing I have to do is square it. And if you square a positive, it's positive. If you square a negative, it's positive. So when you square either one of those, you get 58. Now I have to take away 9 and take the square root of it. And look at this. That's 49. So not only did I find a x value to give me an x value, so that g of that x value gives me 7, I found 2 x values. Okay, so here, since there's no restriction on k, okay, or I should say x is defined for all k, but k is at least 0. The range will be y is, or g of x is, at least 0. G of x will be at least 0. Now, let's change the game a little bit. Suppose I tell you that f of x is 3x minus 1, but it's not from x, the domain is not all real numbers, because right here, just given this, the domain is all numbers. Why? Because I can multiply any number by 3, any number, and then I can take away 1, and I'll get an answer. I mean, there's never been a number that, say, you put into your calculator where you multiplied it by 3, you multiplied this number by 3 and took away 1, and your computer said error. No, that never happened. You can multiply any number by 3 and take away 1. You can multiply 0 by 3 and get 0. And then you take away 1, you get negative 1. But I am telling you that there's a restriction on the domain. It goes from 2 to 5. And the question is to find the range. So you could maybe draw this function. Now people may tell you, oh, you have to pick, to make, maybe we make our XY chart. People will say, oh, you must pick X values between 2 and 5. Sure you do. You can pick any value. I pick 0, I get -1. So that's 1 point. But now this only works if you're using graph paper. And usually in a classroom setting, students are using graph paper. So you don't have to pick 2 and 5. You can pick any numbers you want. If I pick 1, 3 times 1 is 3, minus 1 is 2. So when x is 1, I go up 2. Okay. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this gets moved up. Let me put it over here. Okay. Let me undo that last move. Okay. All right. So we're only supposed to keep the, so this has to go a little bit higher. Come on, stop doing this. Okay. Oh, okay. So this is supposed to go a little bit higher. So now what we want is, we only want to keep this portion only from 2 to 5. That is, we only want to keep this portion of the graph. Now, I guess you really do need to plot those points. What I was thinking about was when you're just asked to graph it. You don't need to know what f for 2 is and f for 5 is. Teacher says, graph this line. Okay, so all you need to do is only keep the portion between 2 and 5. And it turns out that, if you look to the left here, you will see the number 5. Because 3 times 2 is 6, minus 1 is 5. And if you look to the left over here, you will see the number 14. So the range is, it only takes on these numbers. This is the range. I can take on that number. How? By using that allowable x value. What do I mean that this x value is allowable? Very simple. It's in between 2 and 5. I can find f of that value by using that x value. It's in between 2 and 5. This value is in the range because if I take f of that value, I'll get that number, and this y value is in the range. I can get 14 by taking f for 5, and 5 is allowable. Okay, I cannot get 2. because I didn't even hit the graph. I mean, you can say, well, the graph goes like this. First of all, it doesn't. It's only defined there, but even if you did, that's not in the domain. Okay, nobody. Okay. So, the range is from 5 to 14. Y is in between 5 and 14. Number line, 5, 14. It can equal at both endpoints. Interval notation, 5 to 14 can equal both endpoints. Set builder notation is a set of all y such that this is true, such that y is in between 5 and 14. Let's try another one. Now, notice that the lower number, 2, gave us 5, and the larger number gave us 14. The smaller number gave us the smaller number, and the smaller x value gave us the larger y value. It doesn't have to be that way. It was that way because this slope was positive. What if the slope is negative? What if f of x is equal to negative 7x plus 1 and x is in between 3 and 10? 3 and 10. Well, f for 3 we can do is negative 7 times 3 plus 1. It's negative 21 plus 1. It's negative 20. F for 10 is negative 7 times 10, which is negative 70 plus 1 is negative 69. Okay. So, when x is 3, I go down to negative 20. And when x is 10, I go down to negative 69. And here is the line, and it takes on all the values in between. Right here is negative 20, right there is a little bit less, closer to 69, exactly 69. So the range is y is in between the smaller number to the larger number. Negative 69, negative 20, include them. Number line, negative 69 to negative 20, include them. Okay, set builder notation, set of all y's such that this is true, such that y is in between negative 69 and negative 20. Let us try one more. Suppose you're told that h of x is x squared plus 1, but we only want to graph it when x is in between 0 and 5. Here, we need to graph this. Now, you should know that x squared looks like that. But then we add 1. To each point, we go up 1. Each point goes up 1. Each point goes up 1. Each point goes up 1. Each and every point goes up 1 from the x squared graph. So it looks like that, and I meant to cross here. Okay. So let us graph this, just that alone. And it looks like this. The good thing is from 0 to 5, it is increasing. It is increasing. That is, the range is going to be, that's 5. The range is going to be all of those numbers, because I obtained those numbers. This point goes there, this point on the graph goes there, this point goes here, this point goes here. And I'm only using allowable points where the x value is between 0 and 5. This point goes right there. This point stays there. This point goes there. This point goes there. It goes everywhere in here. Well, I know that value is 1, because h of 0 is 0 squared plus 1. Now, what is h of 5? Well, it tells me to square what's in the brackets and add 1. 5 squared plus 1, 26. 26. So, the range is y is in between 1 and 26. Now, what if I made one simple change? I don't have equal here. I just have that x is bigger than 0. That just means that that one point here, this one point is not there. Just like none of this is here. That one point is not there. Okay? So the range would be above 1, just not equal to 1. Between 1 and 26, but it can equal 1. Likewise, if I remove the 5, then I'd have to remove the f for 5, or h of 5, which is 26. But I didn't. They're both there, and there is your range. Now, what we're going to do is somewhere continue what I just showed. I'm going to write down a graph. Suppose the graph goes like this, and then it goes like that. What is the domain and what is the range of this function? Well, imagine you took every point and you went down to the x-axis. You just went right to the x-axis. You don't go this way, you don't go that way, you go at a right angle, right to the x-axis. If you do this with each and every point, which is impossible because there are an infinite number of points, what you would have is the domain marked off on the x-axis. For example, if this is 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. The domain would be, now remember these two endpoints were filled in. So you'd have that as the domain, and for the other piece, this piece, you would have, since 6, that point was not included, but that point was, you would have arrows pointing here. the domain would be x is in between 2 and 4. They equal union. X is in between 6 and 9. It equals 9 but not 6. That is how you find the domain. Okay, maybe, you have light, and the light just points down. So, okay. Oops. You have this big tube of lighting, and all it does is shine light straight down, literally straight down. Where would there be no light on the x-axis? And the curve blocks the light. The curve blocks the light. So where would there be light? Well, you'd have light here, and light there, and light here, and light here, and to the left forever, and light here, but this light beam gets blocked. These get blocked. You'd only have light here, 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 and well, really all the way to the left. Okay, where would you still have darkness? Where it's blue. That is the domain. Now, if you were asked to find the range, what is the range of this function? What is the range of this function? Well, bring all the points to the y-axis. This point which is included goes there. This point goes there. This point goes here. This point which is included goes there. So basically, you will get all those values. Now, this point does not go there because that point isn't there. But this point goes here, and this point goes here, and this point goes here, and every point in between. I can't draw all the points, but you need to get the point. This point up here is included. It goes right there. So basically, I'm getting everything in between here. Everything in between. Now, if I had numbered the axis, the y-axis, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I would say that the range is between 2 and 9. Y is in between and equal to 9. Union 11 to 20, but not, sorry, 13 to 20, but not including 13. So y is in between 13 and 20, including 20. It's just a matter of pushing the points to the y-axis or the x-axis. If I had, let me just erase this, please. If I had some of the graph over here, well, then instead of going to the left to the y-axis, I'd have to go to the right. if I had part of the graph down here, well, in terms of the domain, I would have to go up. I would have to go up to the x-axis. For the y-axis, I'd have to go to the right or the left. That is how, given a graph, you could see the domain. You know, whether you have to graph all the lines like I just did, that depends upon, how much help you need to figure it out. But if somebody gave me this function, it ends here and it starts there, I would be able to see that the domain goes from here all the way below that point. Why? Because if I did this, I took the points and I went of the graph and I went to the x-axis, let me label it, I would have highlighted all the values between those 2 points that I put, between this point and that point. For the range, I would go to the y-axis. I take every point, or I would imagine if I took every point and I go to the y-axis. Sometimes I highlight the same point twice or maybe 3 times, but that's okay. Wherever I have at least one line going to the y-axis, that will be included in the domain. Now the points that I'm highlighting now, they already were highlighted. And this one goes there. So it looks to me like the range goes between those 2 points. I have blue lines along all of this. So the range will go from A to B. And the domain, well, if I call that point C and that point something else like D, the domain goes from C to D. Just project the points for the domain, project every point to the x-axis. Move every point up to the x-axis and see where you have, in this case now, the green lines. And in this particular graph, it seems like it's between C and D. So X is in between C and D. The range seems like Y is between the low point to the high point. Y is between A and B. Okay. This finishes the video, domain and range.